that help develop this experience away from perspective.
So my talk, oh wait, I'm hearing something. Oh, yes. Okay. So my talk is called "We Didn't Need to Exclude You, but We Did," and yeah, it's about accessibility. So in South Africa, there are 3.3 million people living with disabilities from a census 2002, and 2.5 million of those are age 5 and older. So we have a youthful population of people that are living with disabilities. My question to those of you that are in software, do you think that the products you're creating today can be confidently used by people with disabilities? My name is Tshepiso. In the daytime, I'm a software developer at IKEA Sweden. I'm also an accessibility champion. I'm not an expert. I'm learning on the go. And then after hours, I'm speaking like now, and I'm writing and I'm creating content on LinkedIn. So let's get started, right? Disabilities vary. There are different kinds of disabilities. If you watch talks about accessibility, you'll see the slide come up quite often. And it's very important because we need to understand that disabilities can be temporary, they can be situation, or they can be permanent, okay? And there's different kinds of them. In this picture here, who is disabled? Well, thank you for answering. But actually, there's a ramp and there's stairs, right? So both of these people can enter a building. And this is what we call social disabilities. Sometimes we as society and the environment actually cause the disability. And it's not necessarily about the medical condition. And that's going to bring me to digital accessibility. If you working with digital accessibility, you would maybe have seen this neuronym. It's A11Y, which basically stands for accessibility. The 11 is the letters between A and Y. In the digital space, accessibility is when products and services are designed and developed for people with disabilities. It's a practice to ensure that websites and technologies and digital content can be used by people with disabilities, and those disabilities can be physical, they can be auditory, can be like limited movement, but also they can be cognitive, which I think we often forget about, like ADHD and dyslexia. One innate disability you actually can't see from a person. Now, why does digital accessibility matter? Well, I think we can all agree that it's not good to discriminate. If anybody here actually wants to discriminate,
not a good practice. And so people with disabilities should be able to independently and meaningfully use their websites, just like those of us that don't have disabilities. Another reason is a business case. People with disabilities actually also have money. And so if they get onto your website and can't navigate it and they can't buy it, then you're losing that revenue. You get a bigger audience and you get a bigger revenue. And then lastly, in some regions, there actually is legislation for your content or your website or your products to be accessible by disabled people. In Europe, last year, there was an act called the European Accessibility Act of 2025, and that basically required that if you are a company targeting audience or customers in Europe, then your website actually has to be your website has to be developed so that people with disabilities can use it. This caused quite a stir last year, and I don't know if any of you know IKEA, but it's a very big e-commerce business in Sweden, and we basically had to do a lot of work in making sure that our website was accessible. There's regulations, and there's people can actually report your website if they feel like they can't navigate it as a disabled person. And now this brings me to the fun part. I think it's the fun part, and essentially it's assistive technology. When we look at like physical disabilities, people have wheelchairs, right? They have walking sticks. They have I don't know what you call, a blind person. Yeah, that one. I should find out the real word. But people have tools and equipment to use them when they have physical disabilities, right? And so we also have software, equipment, and tools to help people that are disabled to navigate the digital space. And I'm about to share some of that with you. Firstly, one of the most common types of tools is called a screen reader software, right? What it does is it takes the content on the website and then it reads it. So it reads the images, it reads the text, it reads the elements, and then it synthesizes it into speech or into braille. All right. You have to imagine now that you are somebody who's blind and is using the website. You are now relying on hearing what's on the website. In the case of the braille, what will happen is that the screen reader is going to go through the content, and as it's changing, the equipment is refreshing the braille buttons, right? I checked the price of this in South Africa, and it costs 20 to 100,000. So it's not necessarily the most affordable piece of equipment, but lucky for us, our devices, our laptops, our phones, our tablets have built-in sound screen readers. Okay, so you can go try that out at home. I think it's actually quite an interesting thing the first time I did it. And I'm going to now play you a sound clip of a screen reader reading a website. It's not BBC website, okay? But you're going to have to be quiet, please, because the sound is not working so well. Those machines are quite loud. But I'm going to try my best to play it. But that means I need to unmute. Should I switch off my mic? Let me try that.
More image. Heading level 1. S M A R T F A R M I. 12 more items. 22 items.
S M
A
R
T F A
R M
I N G.
Can you hear me now? Can you hear me now? Did some of you hear that? Okay, I'm so sorry. I can play it again for you after this. All right. I should have come earlier to set up the sound. But essentially, I can actually maybe repeat it because I've heard it too many times. Okay, so imagine I'm the screen reader. Okay, you heard heading level 1, S M A R T F, A, R, 22 more items. S, M, A, I'm like the TikTok lady now. A, R, T, F, A, M. That was just like 15 seconds. Can you make sense of any of that? No. And so, okay, I have to put a disclaimer. I have examples here from real websites. I'm not trying to shame the websites. I myself am pushing code that is not necessarily 100% accessible, okay? I'm just showing you real websites so that we can see that this is actually stuff that's happening in the real world. So please don't take offense if you figure out which companies these things are from. But anyway, so that screen reader was reading this. Smart farming starts here, right? So I think it's very frustrating to hear that, but this is what we see. And we take it for granted as visual users of the internet. All right, but I don't come with just problems, I have solutions. So this is the first thing, it's the screen reader, right? But another important thing that goes side by side with screen readers is keyboard navigation, okay? So some people don't and can't use computer mouse. Mice? Mice? Mouse, all right. So some people can't use computer mouse. It could be because, you know, they have limited mobility, think arthritis, think those that have tremors, think people with paralysis, all right? So using a keyboard when they just tab is an easy way of navigating the website. So they just need to be able to press one or two buttons at a time. This is how keyboard navigation is on a popular e-commerce website here in South Africa. It's playing here. Oh, there it is. So as you can see, I'm tabbing through each element. I'm going through. I want to buy something. Did it stop? Oh, sorry. Okay, I don't know why it's not working. I don't want to start it again. Okay, you can come see the thing. But essentially what happens is you press tab and you move next. You press tab, tab. If you want to go backwards, you press shift tab. If you want to actually click on the thing, it's enter. This is what keyboard navigation users expect to happen. It doesn't always happen, but this is what they expect to happen. Oh, I see what happened here. Sorry, my presentation froze. Let's take a break. Are there any questions in the meantime? I'm good with questions. No questions. Yes.
So my question is, what exactly would define a disability? Because like in the sense of, my parents are not disabled, they're just very old. So they're not, so any new technology is always a learning curve, like that they have to undergo. And yeah, there's always a learning curve first. So they're not necessarily disabled, they're just old. So how do you account for people who are just who are just old? They just can't keep up with the current technology.
Yeah. Okay, did we hear that question? So the question, okay, great. That we would call digital literacy, right? So we have accessibility and we have digital literacy, but I tend to think that they actually fall under one umbrella, right? And even, okay, I don't want to ruin my feature slide, but some people actually become blind when they're older, right? And it doesn't mean that somebody who is born blind immediately knows how to use screen reader. They also have to learn. All of us need to actually learn to use our technologies. Maybe now because we're so proficient with our computers and stuff, we take it for granted. But that one we actually call, sorry, 1 second. Yes, okay. Okay, you know what? Let's just see my slide. Oh, there. Okay. No. Did I do something? Okay, cool. Let's go. But we can talk about that one. And that also has its own ways of people learning. Okay, so I'm going to give you now I'm going to go into examples of the most common ways that we exclude people. We don't mean to do it, but we end up doing it. And now we're going to learn how we can correct those things. I went online and I sort of just checked the 10 most common ways. I don't have all 10 here because I do think I'm even running out of time. This one is called low contrast. There is some text here, which is the same as this. Can you see it? You can read it. Can you read this one? Okay, great. Okay, but that's low contrast. I have a gray text on a white background. That's not the best color combination, all right? So you should think about how do you make sure that people that are colorblind or have visual impairments, if they can read your text on your blog. Don't just be using all kinds of colors or your websites. There are things like contrast checkers. So you can actually upload your whole website and software will check if there's any contrast issues. One of the biggest issues people have is with buttons, because we have the background, then we have the button color, and then we have the color of the text on the button. And that can be a lot of things to try balance out. The next one, this is my favorite. This is text alternatives. And I like this one because it applies to all of us. Whether you're a developer or not, please use text alt on your pictures. When you're posting on social media, on LinkedIn, people are reading that, and people that are disabled are reading your content. This is from a website in Sweden, just so it's not like I'm just collecting South African websites. And this is the text that the screen reader would say, product image. And then there's another cake, product image. And then there's another cake, product image. What am I buying? If I'm blind, how can I tell which cake I actually want to buy? So instead, what I would do is I take the picture, I throw it into Tshepiso, please provide alternative text. I read it, and then I paste it here, okay? If you find that creating descriptive text is difficult for you. And yeah, for those of us that are developers, use your semantics. Semantics are there for a reason. Another one is using text instead of images. If you have something important to say, there's 40% off, but it's in an image. Some screen readers can't read text on an image, right? So rather use p tags to write your content and then decorate it with CSS. Don't put images with important information that the screen reader won't have access to. Some people won't know that we have the sale, or there's an emergency something, if you put it just on a picture. Okay, and then this is another one of my favorite ones. So imagine you have a paragraph, and then there's a link somewhere in the paragraph, and then you have another paragraph, and there's a link there, right? I used to do this. I used to do this. I would say, click here to read da-da-da-da-da, or find my website here. People that use screen readers don't go through all of the text on the page, right? They're actually able to jump from link to link. So if you are just going to have click here and here, that's what they're going to hear. They're going to hear link, click here, link here. What is there? Okay, so we rather want them to hear link, read our full mission, link, Tshepiso's website. You're telling them where they're going. You're telling them what the link is for. Again, this is not just for software developers. When you're writing an email, try to start using these things so that your links are descriptive. When you're posting something online and there's a link, use the title of the thing that it's going to. All right. Here's another favorite of mine, and I had a video, but maybe it won't work. It's called skip navigation. So you have your first row of products, and then you have your second row of products. If I want to buy that suitcase on this one, and I'm all the way there, don't you think it's a bit boring that I have to tab through each and every single product to end up there on the suitcase, right? So what we tend to use for especially e-commerce websites, pages with a lot of repetitive content is something called skip navigation link. So essentially, I tab, and at some point, you can't see it visually, but somebody who's using a keyboard, when a certain button gets focused, it will pop up, and then it will say skip to the next category or skip to the main content. 5 more minutes. Okay, cool. So yeah, that's the skip navigation so that you don't have to go through all of that content. This is the code. Oh, here's one for LinkedIn. Did you see? Okay, let me go back. Oh, okay, there. So I go through that, and then there's something says skip to LinkedIn news. So if I click on that, I would end up then in something in the main content of the page. And this is not the code snippet from the LinkedIn page. This is just a generic code snippet for those of you that want to try it out. Lastly, I can't have a conversation about accessibility without talking about forms. Forms are very important. Contact forms are forms. When you enter in your bank details, that's a form. You know, we have all kinds of forms. I have to do a lot of admin while I'm here home at the moment. And all of the websites I've had to do, drivers, passport, blah, 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 they all have forms. And one of the most frustrating things about forms is when I don't know what I've done wrong, right? So you should have clear error messaging and make sure that the message is available to the screen reader. Don't just put a color around the input field. The screen reader is not going to say the block has changed to red. Also, some people are colorblind. They won't even notice that the block has changed the color. Try to use inline messaging or like pop-ups that can be read. I have this cheat sheet. You can download it. And basically, it relates to the web content accessibility guidelines, right? So there are some standards and guidelines that we use to know what exactly we need to do. That's a lot of information that I gave you. But there's actually guidelines for you to figure out, if I want to get to this level, what do I have to do on my website, all right? And they have 4 principles. They're called perceive, operable, understand, and robust. So perceive is, can the user sense the information? Operable, can the user actually navigate your content? Understandable, are things clear? Are they simple? Don't have a very generic error message like this is wrong. What is wrong? Help me figure out what is wrong. And then robust. It means that your website can be used by different kinds of assistive technologies like screen readers or different input equipment. Now coming to the conversation about aging. At the moment, I am not a disabled person, but I care very much about accessibility. And that's because that one thing I can't run away from is that I'm going to get old. And it's very likely that some of this will be part of my reality. And so if I know I'm going to be old and I'm using the website and I'm using the internet right now, and I still want to continue doing that, it means that we have to be doing the work right now. We are coming from a generation that has grown up quite a bit online, and I believe we want to stay online. The last thing we want is to suddenly not be able to access things because now we've reached, now we're also disabled. And that was me. You can connect with me on LinkedIn. My name is Tshepiso, and thank you so very much for your time.
Okay. Awesome. Thank you so much. Hello. Thank you. Okay. Thank you, Tshepi. So our next speaker is a Rust programmer by the name Mr. Tembaletu. We know him, or at least a lot of people know him. He's also a PyCon for Africa 2025 speaker. and he's into APIs, LLM, security consultant. And yeah, he's going to be speaking about, let me just find your topic, how Rust infers types to deliver programming safety. I think you can say it better than me. You can use this one.
Good evening, everybody. Okay, so I'm just gonna have to hold this on my hand. Okay. Yeah. All right. Thanks, Batandwa, and good evening to everybody here who came tonight. My name is Tshepiso. Like Batandwa said, I'm a Rust developer. Louder. Jeez. Okay. All right. Is it better now? Okay. I do work in Rust, but Rust obviously is still like very niche or very small in South Africa at the moment. But we've got a small group at Microsoft. Everybody wants to come and join a Rust user group. It's every second Tuesday of the month, 6 o'clock. Come for the Coke and the home pizza. So that's an invitation out for you guys. But really, why am I here tonight? Rust is known as a memory-safe language. So if you develop in Rust, you're highly unlikely, or at least you reduce your chances of creating software that has memory bugs, especially memory vulnerabilities. So Android, Microsoft, and a few other companies, and they've just done kind of like find out what amount of time before they use Rust. They were using C++, of course. But then when they adopted Rust, they found that they reduced the debugging time of these memory vulnerabilities by about 79 to 80%. So that's a huge saving so that you can actually do the development work. So Rust is big in that, and obviously a whole lot of other companies are actually picking up on it. So Rust is based on a type system. So basically whenever you write your code, you have to be explicit about the data types you're using and what they mean and what they stand for. So they force you as a developer. It actually, when you learn and develop in Rust, it changes your entire, mental framework of what it means to be a programmer, because you become responsible for the code you write, and the compiler is there to help you. Some people get pissed off with that, but really it's kind of like a coach or an assistant, and that stops you from harming yourself next week or next year, because you're going to be debugging this code with vulnerabilities you don't really know where they come from, and you wrote it. So it works on lifetime and ownership system. So every variable in Rust is owned. So like anything that's got an owner, you can't use it without having the permission to do so. So there's a thing called you reference a variable. That's when you want to use it, but it's not yours. So, but I'm not going to get into the details of that. But really, lifetime and ownership is very big in Rust. And also, I say here, there's something called. So I'll just read that. These systems allow the developer to share memory directly across FFI boundaries with questions of where the responsibility lies. So FFI stands for Foreign Function Interface. So in Rust, you are able to write C++ code. Like when you port, let's say, any devices, or let's say your Android phones, for example, because Android actually just changed to Rust as well from C++. So now, when you do FFIs, Foreign Function Interfacing, it's a boundary between Rust and the original programming language, like C++, where that code is written. So that's the interface there. And there's a lot of work that's done, obviously, to make sure that any data structure that Rust uses, that C, for example, if you wrote a code in C++, it should still, when it's converted to Rust, when you wrote it in Rust, it should still hold the same contract. So the contract should be valid. It should work exactly the same as C intended. So that's what the FFI actually implies. and make sure that whatever was written in that original language will still remain true and valid. And the contract is maintained in Rust as well. So obviously, threading is a big thing. Like for instance, so when you read threads during, like for instance, when a bank communicates to their customers or any large institution that has to speak to their customers, so a multi-thread in there becomes important. In Rust, we call that fearless concurrency. But we do that with confidence because there are no memory leaks, no use after functions. There's nothing that really happens during the multi-threading process as well, and that all comes from the memory safety and the trust that you can have. So then the question then becomes, how does Rust infer these types? Because I said that the types is a type-based system, language. So how does Rust infer these types? So imagine a scenario where you're actually writing your code in an IDE, and you're using these type, variables and data types and all these type of things. So you can either annotate your the data structure that you need. For instance, in this case here, basically the inference basically means it's the process of automatic detection of the type of the expression, like the code. So as you write the code, Rust or the compiler will kind of like, depending on the structure of your code and what kind of like fingerprints you leave, I use the word fingerprints, you use in your code, Rust can infer what type that code should use. Let's say, for example, I've got let x equal 5, then let y, equate that to a string. So these little colors here basically is the same data that's stored, is how it's stored on the heap. Heap of the program. Obviously, each and every letter of that string, is by index. So in that case, for example, when we say x equals 5, Rust knows, without you saying it explicitly, that the 5 is actually an i32, is one of the metadata types. It's like an integer, okay? And then the y itself, because it's not an integer, it's a string slice. So Rust will kind of like help you with that without you having to write it. So you get to write less code, but you do it safely because the compiler is assisting you not to make any mistakes in the process. So like I said, you didn't write let x equals i32 because Rust infers from what you wrote. So that's a small signature you left there for the compiler to actually figure out, so that the next time you use a variable, it knows I'm actually expecting an i30 like an integer in that case. Sorry, I went backwards, and then so yeah. Look, I'd like to pose the question. Sorry, the idea that when Rust actually do the in your IDE, in your code, it looks at every piece of code you're writing in its local scope. It doesn't look at the global scope of the entire program. It just looks at what at that point in time you're busy with, you're writing, and actually solve the problem deterministically. That means there's a methodical way in which it does it. So it doesn't guess the kind of variables or the kind of structures, in your language that other dynamical languages might do. So it does this by way of building constraints from what you write. Like I said, in the previous example, we said let x equals 5, and then let y equals hello. So those two things suggest that locally the x will be an integer, and then the y will be a string slice. So after it collects a constraint, we're going to go into the next slide to actually show that and talk more a lot about that, how actually the idea of reducing anything to a constraint, because constraint means kind of like you just look at what's in front of you. That's what the compiler does. Doesn't worry about what's global happening in the program, just looks at your scope at that point in time, and then solves that. It's like solving an equation, really. I think a lot of you did mathematics at school, but really that's a process that it follows. It's more like solving an equation. And so the mechanisms, one of them is the constraints gathering, like I said. So the compiler then examines the code and then it collects all the type relationships implied by the expression. I'm going to use an example here. I'm sure you're familiar with that word if you use Java or JavaScript. So let mute is a keyword in Rust, which suggests that if you have the keyword mute, it says whatever variable I'm using at the moment, then assign data into it. I reserve a right to come back later and change it. So it allows you, without using the mute, you can still use it, but the problem is you can't come back and then change it. So mute stands for mutable, changeable. So this variable v is changeable because I might change my mind and allocate it or assign it to something else later on. So in this case, I'm saying let the mutable variable, which is v, and assign it to like a string in Rust. An array. It's called a vector. So vec new. Now I want to use a variable v because I'm going to use the method push. So push one inside the brackets there. So the mere fact that I put one in there is again one of those fingerprints, signatures that I leave throughout the IDE for the compiler to pick up that the next thing I may do with the push method, I'm going to push into an array the number 1, which is an integer. So Rust is going to help you with that because you've given it a clue that I'll be putting some elements perhaps on an array, just full on integers. So in this case, vec new, at first, if you don't have inside the open close bracket, if you have got nothing in it, at that time the type you're going to use, is unknown, or the compiler doesn't know it yet until you give it a hint. When you then deliver v dot method push, you put the 1, and then it just summarizes that obviously whatever should go in the brackets will be an i32 data type. So the compiler is just inferred that the vec will be an i32. Any questions so far? No? Okay, lovely. Okay, so the other, sorry, did I jump something? Let's see. Oh yeah, sorry, jump something. So the second bit is unification. So remember, I said Rust is kind of like thinking algebraically. It collects the facts, see what you've actually suggested on the IDE, on your code, you're writing your code, and picks up clues to assist you. And then that's the first, that's when it gathers. Oh yeah, on the constraints gathering, the data type could have been an i32, like an integer, could have been a boolean, could have been a string, could have been, what else? A float. Yeah, lovely. So because we had none of those, but we only had the integer. So by way of unification, gathering the constraints, Rust will help you and say, okay, fine. None of the other ones apply, but only this one. So the unification, then the part about unification, Rust, the compiler will try and unify all the constraints that are available, like the ones that I've mentioned, and see which one is being suggested by your code as with the code that you write, and you will remain consistent with the one that actually is relevant. Next one, and then what happens then in the event where things are a bit ambiguous? So when things are ambiguous, like for instance, I just say let x equals 0. Rust applies the default system. So if it doesn't know what it is, like it can't tell. So you haven't given any clues at all. It will just, if it's for integer literals, it will just revert to an i32. So an i32 will be a big enough data type to initialize memory in the heap and then be able to do the store the data. Can people who are talking just give us maybe another 10, 15 minutes? Is that okay? Thank you. All right. So I just want to digging a little bit here on the I32. So Rust, if it's a string literal, sorry, an integer literal, an I32 will be assigned. So an I32 will be a data type big enough to hold the data in the heap. Because remember, the other thing you have to think about is, I also have a background in ethical hacking. So the guys who do bad things, but I make sure that they don't do it. So, bad hackers, not ethical hackers, like bad hackers would actually look at your program and how it's structured and make sure that they can overflow what we call data overflow, sorry, buffer overflow. So whatever, like consider that I32 is some kind of baguette that's big enough to hold in the data. But if, say, for example, Rust had given us like an I8, which is like very small, okay? So in the event of a bad guy, then can make sure that they can do buffer overflow by just bombarding your heap with data that they know that the program can handle, and then it crashes. And that's a problem as well. So if it's a float, the default one is an F64. Float is just integers, decimals. So now the fourth one we'd like to talk about is local scope limitation. I think I started with this concept. So where everything is reduced to the local scope. So it doesn't look at the global, because global is huge. It can be libraries, it can be other functions that exist in a program. So that then becomes very difficult to deterministically solve and isolate and make sure that this is a data type Rust can infer you, can influence and help you with. So that then becomes a huge task and is costly as well. It takes longer. So by keeping it local, it makes it cost efficient or resource efficient and reduces the idea that mistakes could happen. So if, say, for example, we have a function called make, and then we say let v vec new equals vec new. Compiler cannot infer what type v is. There's no hint here. Like initially, we had a method called push, and then we had an integer in. But in this case, we have none of that. So it's kind of vague. So in this case, then, if Rust cannot tell what v should stand for, then it will give you an error messaging. It cannot infer the type parameter, what the type is required. So then we have to solve that. That's how one of the ways that compiler can actually help you. It infers and then it gives you an error if there's nothing you can work with. So basically, Rust is saying, give me something to work with here, so we can kind of like do this together. So in this case, then we need to specify. We need to annotate that v vec I32, and then obviously that becomes obvious. Rust, the compiler will know what to do. So the next thing I want to talk about is how types propagate through the code. So I have an example function here, a dummy function, let mute. I said the word mute stands for I reserve a right to change it, to change it. That is like mutable. So the variable is sum, and then we say that equals to 0. This is a case of a for loop, for example. Then we go for I in 1 up to 5. So sum everything in that range. The numbers 1 and 5, or up to 5. Please sum all the numbers in between. And then we call that function and say, please print sum. So this is how this inference chain works. So where, for example, 0, because it's a number 0, it's a default I32. So the range 5, it creates an inclusive. I can't remember exactly how it works in other languages, but in Rust. So if you create a range with 5 without the equal sign before the 5, so 1 is inclusive, but 5 without the equal sign, 5 is exclusive. So you do count 1 to 4 and exclude the 5. But then if you put in the equal sign, it means the whole thing is inclusive. That's your algebra, you remember that. You did that at school. So therefore, the I must be the same on both sides. So it basically means that whatever you do on both sides of the equation has to be of the same type. So when you do the addition, sum plus equals I requires both sides to be of the same type. So if they are not, then there's a clash. So you're going to get an error because the types are not the same. Therefore, sum, the variable sum, should return an I32. You see, there's still no questions. Can I carry on? Yeah. Okay. So why Rust then chooses local inference, not global? I think I said it earlier. I presented the slide even before I got into it. So because the constraints work for you to solve things locally, and it's a resource what's the opposite of expensive? Resource efficient, I think. It's resource efficient, and also it's easy to solve. It's we're just dealing with the local condition, and the error messages are clear. Because if it has to look at function in other libraries and functions that are not necessarily local, that's going to take some time to do and solve. So it's type safety strong. You must specify the public function signatures, thus making interface explicit and stable. Again, on the same idea. So if you have a function boundary where we say it's a dummy function add, where you're adding A and B. So you put inside the scope A plus B. Obviously, this will fail because Rust cannot tell what A is and what B is until you explicitly, like I said earlier on, you need to be explicit. So we mentioned that A is an integer, either true, so is B, and then you expect the result or then which should be of the data type either and then A and B. So Rust can infer across boundaries. If not, you must declare it. So this is one advanced case where we talk about generic type inference. So this advanced function just simply means we go to standard library and import some formatting or some capability and some debugging. So all of this is actually now using resources that are available in the Rust ecosystem, where you need a debugging function, you need a V. You just say inside the brackets there a V that returns a vector of a certain type, and then you can print the colon question mark, then you call the V. It's just a way of saying whatever the variable is, please print out on the command line. So and then the next example would be a dummy function again, let numbers. Those numbers will be an array vector, 1, 2, 3, print var. So here, the type is inferred. Those numbers, 1, 2, 3, so they're integers. They're either, and then those are just generic parameters that actually benefit from inference, as long as the compiler can deduce from the context. The context obviously is exactly what you wrote above, which is vec, let numbers on vec, and what we have inside the array as 1, 2, 3. So this is just a summary of what we've done so far. So the concept example in Rust. So for literal defaults, let x equal 5. If Rust doesn't have anything else to go with, it will just default to an I32. But then if it's a contextual inference where we're using a method, for example, where we use the v was our variable, and then we push 1 or 2 or whatever it is, and then Rust will know that inside that method we're pushing an I32. And then in terms of function boundary, you need to be explicit. And generic inference, and then we can use help from the standard library where Rust can also infer, depending on what's available, what's in front of it, that the type could be an I32. So for lifetime, there's another complex thing. Rust is not complex, actually, by the way. It just takes too much time to learn. You just need to pay a little bit of attention. So, but there are things called lifetimes. Also, lifetimes, okay, sure, are part of the whole safety and borrow and checker process. And the last thing I want to speak about, just briefly, I've got 4 minutes. So there's an underscore hash. Sorry, the underscore is red here. So that's like a type, it's a placeholder in Rust where, for example, if let's say you don't want to decide what type it is or haven't decided yet, or you don't know it as a developer, Rust will say, okay, we'll kind of like postpone a decision deciding which type this is. We'll wait for more data to come through, and then when the time happens, and then we'll decide. But I think we've laid the ground already by showing the condition and the mechanism that Rust uses, such that it allows you this kind of functionality where if you don't know what type it is, you can decide later. The compiler can help you later. And you're also just telling the compiler, please infer the type. So common scenarios of this underscore or the placeholder is invariable type annotations. You can say at n underscore equals 4. So Rust will actually then, because you didn't tell Rust anything, you just put an underscore, but Rust will tell, because there's an I32 there, that must be an I32. And then you're basically just asking Rust, obviously, to infer from iteration that happened. And also when you're doing function calls with generics, so you can also put the underscore inside those angle brackets, and you're not giving it any hint. This says create a vector, but the compiler fill the generic parameters later when you know what type will go in. So basically, the compiler is here to help you. So it's giving you all these tools that you can decide later, maybe not now, but later. But all the decisions that the compiler will make will be dependent on little signatures or the fingerprints that you leave throughout your code. Okay, I think we spoke about this. Okay, another pattern, down to 1 minute now. Yeah? Okay, in pattern matching, when the underscore appears, not in a type, but as a pattern, it means ignore this value. So Rust in this case, let A, so that brackets that there's A, there's an underscore, and then there's C. So in the case of the underscore, it just says, okay, just look at it, ignore the other bit, and just carry on, keep it moving. So also you can use it as a placeholder. Like I said, I think we said that earlier on. There's something called closure in Rust. Maybe I don't have time to talk about those so far. Ladies and gentlemen, I think I'm going to end the presentation with my last slide, and thank you so much.
Well, we said I have a question.
Sure.
Okay, hi. I want to understand the mute and the underscore, right? Okay, so my question is, but you'll correct me if I'm wrong. So if I say X is mutable, right? And I decide that the X is 5, the code will then check and see what data type it is, right? So if I now decide that I want to change X to a different data type, then it will not allow me to do that, right?
If you use the keyword mute, that's kind of like making clear from the beginning that you can change this, or you will change this. Maybe sometimes, maybe in your very next line of code. So as long as you have the keyword mute, that just give you permission. If not, then it's going to be an error. A string? No, well, no, because the data type, depending on what you do, so you can't mix data types. Like for instance, you can't mix like an integer. Let's say you can't say let x equals 5, and then let x, because x is 5, then let x equals 1 plus 1 comma 2. So that's both an integer and a float, and you can't mix these two. So that's going to give you an error. Gotta be the same data type when you do that.
Okay, so this works the same with the underscore to actually say, yes. So now we're saying, I don't know what the data type is, right? But in future, I will change it. So it will still give me an error if I change it from one data type to the next. And is there a way to just change data types with like the variables that we use?
You have to be explicit what you do, and you can come with surprises. Because surprises mean change of something in the heap and how the memory is stored. So you can't surprise it. You gotta be clear. As long as you're you're explicit, Rust will work with you. But don't conflate data types, and don't forget not to use the word mute if where it's necessary. Yeah, everyone wants to. Yeah. No.
I wanted to ask, does Rust only apply to
JavaScript, or does it apply to every type of coding?
No, no, that, for, okay. So I think the question you're asking, does Rust apply to JavaScript or, yeah. Okay, so Rust doesn't work directly with JavaScript, but there's something called WASM. It's like a virtual machine where you can actually use Rust and use through that virtual machine like a converter, and you can then work with JavaScript. But the languages that have got permission to work with Rust, permission quote unquote, is C, C++, I think Python, I think Ruby as well.
Okay, hello everyone. Okay, so I'm not really sure if I understand, right? So using that, it's basically like using const in JavaScript. Is that the constant value? Yeah, yeah. No, like how this works. Is it more like setting everything as a constant? Yeah. Okay. 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 Mm-hmm. Okay, because I wanted to reference with, right? Cool. So since you said you can't change it, right? Oh no, so you using the mute, you can change it, right? Mutable. Cool. So are you able to change the data type, or is it only the value?
You can change the type as long as it does not conflict with, like for instance, if in the line of the writing, second line in the first line, it must be the same data type. But if they conflict, even if you can get an error, but the data type should be free, the contract should be of the same data type. Okay? Mute just means let's X equal 5. And then next time X is going to be equal 7 or equal 5. It's still the same.
Okay.
As long as but you can change the
Okay. So does this mean okay, let's say you were using an integer, right? Basically you can change it, but you might mess up some of the logic that works with that certain data type. Because the functions will still work as, but once you change the data type, it's like the whole code is not gonna work. Okay.
No, no, no. So if you guys still have more questions, I mean, we're going to be chilling out, having pizza and beers, not beers, drinks. Um, you can still have a chat with both our speakers. Kemalet is here and Tshepiso is that side. Otherwise, thank you guys. Enjoy the rest of the evening. A round of applause for both our speakers. Cool. Pizza, drinks, and the bathrooms are that side. Thank you.
Like, sorry. Like speed work. What? Let me go get my phone. Like behind the bus so that we don't have to do anything. I need to get my phone now. Whoever was saying that, my phone was and like the oh, see it. Sorry, guys. Please, you don't have to wait for you can come around and then get some pizza here as well.